Hello, and welcome to this week's installment of ClueCon Weekly. This week with us, we have Taht, founder of Bufferbloat, and he has a very long history in VoIP and networking, and I'm very glad to have him here today. Thank you, Dave, for joining us.
Thank you so much for having me, Luca.
That's a great location to have ClueCon Weekly from. It's the first time I have someone on a boat, so I think that's kind of a dangerous demo, the kind of thing that happens at conferences.
Well, I do network research, and trying to make video conferencing work well over LTE is one of my things. And I'm hoping that this video conference goes well. If not, I'm taking packet captures, and I have a couple thoughts towards improving your product along the way. Let's see how it goes.
Wow. That's fantastic. This doubles as research too. So would you like to give us a quick introduction about yourself before we start?
Sure. Well, I've been kicking around the internet since 1985 or so. I was involved in early stage VoIP and stuff. You remember CUC-me? You're probably too young to even remember CUC-me.
I remember, think I've heard the name, but I haven't seen it. Right.
I remember sitting in my office in 1993 or so, looking at this postage stamp, 2 frame per second, black and white thing, and jumping up and down saying, "This is the future. This is the future." And that's an airplane, but this is the future going by. And I was like, that's really lousy, Dave. Go back to reading that news. Do that. And so I got heavily involved in voice over IP in the late 90s. In particular, I started working on FreeSwitch, and I was one of the first people to make, not FreeSwitch, my apologies, but the predecessor. And one of my first claims to fame was getting that to run on an embedded processor that flew in an airplane on an ARM back then. So that was pretty neat. It's in the Gulfstream. It flew pretty high. It's the highest my code ever got. That's not at that point. After that, well, I was going around at the time saying, Linux is going to go into space. And everyone looked at me as I was crazy. And now everyone knows that SpaceX flies it. I have a couple songs about SpaceX. I brought my guitar today, too. I don't know if your recording quality is good enough for me to do a demo of that. But anyway, I moved to Nicaragua, and I was working on the One Laptop Per Child project. And my network sucked in rain. I didn't know why. It just sucked. And of course, the rain there goes on for about 2 months straight. And after I folded up shop there, I came back to the States, and I realized that, wow, everyone's network was really sucking for VoIP. And my colleague, Jim Geddes, who's the co-founder of Bufferbloat.net, the original guy, had figured out why the internet was doing so poorly for VoIP and video. And I realized that through repeating his experiments that was what was wrong with the internet for interactive applications such as this. And I offered him a couple servers, and it's 10 years later. And the code that, do you have an Apple or do you have an iPhone, or do you have an Android yourself?
I have an iPhone and an Android phone. I have both.
All right. Well, so one of the algorithms we developed is in the iPhone, and so therefore all your packets go through me, or us, I should say. And we've done a lot to decrease the latency. At some levels, it's a terrible responsibility. When you have, well over half the world running through algorithms your project has helped design, you lie awake at night and say, well, did I really get that part right? And been dealing with a couple mistakes that we made actually for the last year or two, and all of our packets going through these algorithms. And anyway, these days I'm hacking on Wi-Fi and LTE to improve their abilities to do not just interactive video, but wait I'll be right back.
Wonder what's in store.
Well, my goal, going back to 1991, was to build a network that would let my drummer would never, ever show up for gigs. And all I wanted to do back then was I wanted to plug my guitar into a wall and play with him, because he didn't want to set up and tear things down. And the speed of light across town is microseconds. So it's just like being in a band together. But the internet, as it evolved, didn't work out that way. We have these enormous latencies built into our encoders and decoders that it's like shouting across a room. And that's not what you need to do to play in a band. So one of my ongoing jokes. Do you get these two references?
I don't think so.
I'm hoping we all. Half half your audience will get one of the jokes, the other half will get the other one. There's a famous guitarist named Woody Guthrie in the United States, folk singer, and he said that on his guitar was "This machine kills fascists." And Vogons are the evil bureaucrats that in Hitchhiker's Guide to the Galaxy that destroy the.
You're right. Yes. Now that you say so, you're right.
So if I have any one major mission, I'd like to get what I call a jamaphone operational for everybody, so we can have nearly real-time communications between people across town. And
yeah, you're right. I've always wondered to a degree why there was such a difference between the actual speed of signals and the speed of transmission on the internet. Because generally speaking, I mean, the light from the sun makes its way here in 8 minutes, so it means it's quite fast. Yeah, a few miles away, you're looking at 50, 60, 100 milliseconds easily.
Yeah, easily. It's usually much worse than that. And on your typical fiber network, you might get 2 milliseconds across town. Just not bad. I always equate milliseconds to feet. So like that's 2 feet. And if you want to play in a band, 8 feet is about as far away as you want to be. But just to get across town on the fastest technology we have, we typically see about 2 milliseconds. For fiber, cable and DSL are vastly, vastly worse. And since the algorithms that we developed have been shipping for a lot of products and stuff, aside from wireless, the problems have moved to the video codecs and the congestion control algorithms that we have. We are, I don't know what our lag. You're presently in Europe somewhere in Italy?
Yes, no? Italy, northern Italy.
You don't have a lag meter on this tool, do you?
No, yeah, not currently. It's somewhere in the RTMP for sure, but RTCP for sure. But it's we don't have it visible. No. Yeah, it would be interesting to figure it out.
It's a good number to be tracking because it isn't just the buffer bloat that I've been coping with. It's all of our stuff is just designed to have just too much work being done. If you got a gigabit, I can send you, 1/4 gigabit. I can send you a really high resolution thing with 0 encoding and 0 delay. There's a wonderful project called the Lola project in Italy. Go looking for that one. Lola.
Oh, really? I'll take a note.
Have a concert orchestra that plays across the country, physically across the country. So add that one to the call. They were one of the inspirations for my own work for the last 30 years. We're perilously close to where we can build a networked orchestra where everyone can stay at home, stuck at home, and play in a band.
That has been much of a focus of an industry, to be sure. I mean, as SignalWire works through video and events, and we have product called events that people use for all sort of concerts and broadcasts. And there's something we've been discussing with people, like, could we have different musicians play together at the same time? Actually, it was singers in our particular case. But we were asking if we could have 2 people sing together.
It's really difficult. You have to. Yeah. Professional singers can do it. It's a minimum 40 milliseconds of latency. Which again, 40 milliseconds is 40 feet. It's really hard to sing across that. So getting it down below 2 milliseconds is really, 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 really difficult. I keep hoping that more and more people will join me in this quest because I like playing in a band. I like playing in a drummer. I like having a drummer. I love having a lead singer. And if we could have all 4 of us collaborating together.
Yeah, that will be. So going back to our looking at how the speed of light is very different from the speed of the internet. While in theory, it shouldn't be. What is introducing that latency? And does it have anything to do with the term buffer bloat, which I've just, because it sounds like that's the problem, right? Because other things are just electric and light conductors should just work, right?
Well, I could start at the bottom, or I could start with the term buffer bloat. It's a very Googleable term, and the core solution for it is an algorithm called FQ_CODL. It's a standard in the IATF called RFC 8290. It's also my license plate. And it's running on just about everything except where it needs to go. And I'm trying to explain buffer bloat. I've explained it so many different times. I just swallowed, right? Now, what we do when we swallow.
Oh, I see. Yeah.
is we take it in and then we swallow. We don't do this.
Yeah.
I know. I'm sorry for anyone that's offended by my open mouth, but anyway, the ideal transport is a steady stream of water pouring directly down my throat into my stomach without ever stopping or pausing or jittering. Okay. And we unfortunately have all these layers in our stacks and our hardware that prevent that easy direct flow of water. It's almost always better for a computer
to hold
with something and then swallow. And that's basically what started to happen with buffer bloat in the beginning. We had little buffers, and then people said, well, let's have bigger buffers, and that means you can drink the whole can.
Yeah.
Then swallow it. And that's more efficient for power. It's more efficient for device developer writers. Getting where you have that smooth flow of sound, music going down your throat is much, much harder than it is to store up a big thing and swallow it. That's probably the more unusual demonstration of it. There's a couple really good bloat videos where we use water, and we have other stuff where we use marbles. I got a pretty good one where I use people to explain it. It's if you look for apneic buffer bloat, I gave a pretty good talk where I grabbed a whole bunch of Australians and turned them into pockets.
Oh, that sounds great.
Well, there's actually a really complicated theory behind all this. One of my kvetches during the whole COVID crisis was that, are you familiar with the term Q theory?
You broke up right at that moment. Sorry.
As soon as I start talking about it, the internet breaks. Because, boy, we can't talk about that. Now, Q theory, Queuue. Yes? I came through this time?
Yeah.
Okay. So this goes back to Erlang, 100 years. And Glenn Kleinrock, one of the original developers of the early internet, ARPANET, I should say, really refined it. And it turns out that his books are mostly out of print, and they go for like $500 on eBay. But Introduction to Q Theory 101 has three really good books on it. And I was like really stunned during the entire COVID crisis. Have you ever, so four things. Have you ever stood in a line and wondered why it was taking so long?
No.
Yes? No, you never stood in the line and wondered? Okay, well, I hope more people did, because I did. It's a really rare skill. Traffic, you get into a car, you go drive past a car crash, you see your traffic slowing down.
Oh, yeah, too.
You see just-in-time manufacturing, that's also Q theory. And the entire COVID crisis was Q theory 101. You know, we had
why, if I may ask?
It was a potentially exponential rising rate of infections, okay? Entering the queue, which is beds, hospital beds. And then after that, the egress rate from those beds. And you have to somehow match the ingress rate to the egress rate. Q Theory 101. And nowhere in the world did anyone ever connect the dots for a student that could maybe go look at the 100 years worth of stuff and scratch their head at some of the really stupid ideas that went around that for people that hadn't read Q Theory 101. It's a bit of a digression, but basically, it's a really useful skill for a programmer to have, a manager to have, someone doing just-in-time manufacturing to have. And I periodically, it's what my background is in. I periodically go to dice.com and look for a job, and I look for Q theorist. And there haven't been any for like 8 years.
Oh, yeah, it doesn't sound like it. Sounds like it's a very specialized set of skills.
It is pretty specialized, but I do feel as though we could use a few more. There's some really famous people that have that background, Van Jacobson in particular. And the rest of us just keep banging the rocks together. It's very lonely mathematically for me. How I got to this digression was that talk I gave at APNIC. None of my talks do I ever use a single equation, ever. And it's lonely. I would really like to talk about m/m/1 Qs with somebody, maybe the girl of my dreams. I don't know. But I keep hoping to inspire people to look, in particular, at Glenn Kleinrock's work. I think it'll improve not just networks, but a lot of different kinds of programs and so on. So that's my plea today. Please go forth and study Glenn Kleinrock's work on this subject and be enlightened.
We will. So just to sum it up, the difference between the speed of light and the speed of the internet lies in the fact that every device that whatever you're sending encounters has to keep a few packets in buffer just because I need to figure out the order, need to reorder. There goes 3 milliseconds. Then the following router, there's another switch who has to figure out where they're going. Keep them there while you find out your destination. Other 3 milliseconds gone. Piled up, and it gets very very long very quickly. I can see that happening, especially because these days you have anything takes like 20 hops.
Yeah, well, it's not. I can. You're overreading. Most of our switches are actually pretty fast. So where the buffers were accumulating the most when we started the project, the all-time record for excessive buffering was actually held by Viasat.
Yeah.
They're not buffering in one of their satellites. They're geosynchronous satellites. They had 860 plus seconds of buffering in it.
Oh.
Most of our protocols were designed for our internet protocols were designed for one time around the Earth physically, which is about 240 milliseconds. And at the time we started, we were seeing not in Wi-Fi, we were seeing 10, 30 seconds worth of buffering. You know, it's sort of like, you know, me shouting at you, and then
yeah,
you know, so on. Cable modems were in the 2 to 3 second range. It was awful. Again, a level of immediacy from a human resources, from a human interface perspective, is about 30 milliseconds from the time that you do something, rubber banding, playing whatever. 30 milliseconds is a good number. And I think in part some of the buffer bloat problem is that we've been trying to train people that sending all their data out to the cloud and back is a good thing. And therefore you should really relax and wait for the ads to load. But I really like.
Is there a mathematical, a not so mathematical way to explain at least the start of the solution you've developed and you've been working on for so long? Like, how do you fix the problem in somehow explainable way?
We'll see what happens. Again, I have a couple really good videos that do better than I can do in a short interview, and so we'll do that. But and I gotta also say there's been a ton of really famous internet originals involved in this, starting from Vint Cerf on down, that really cared about fixing this problem. And we all agreed together that we were going to work on it, make sure it couldn't be patented, and give it away, because it was the buffer bloat problem was a leftover problem from the early 90s, from the early 80s. So the solutions is that, yes, you need a little bit of buffering, just a little bit, just enough buffering, you know, so just a
little sip.
Okay, just little sips, and you can keep taking little sips. And that insight is good. The second part of it, though, is that we have two different major kinds of flows. You have a big fat flow, which is doing a download, right? And next to that, you have a little VoIP flow. And those are distinguishable by the IP. I'm getting geeky on you, by the IP header. So flow A, the big fat flow, to the VoIP flow like that, would get stuck behind the big flow, and you don't want that to happen. So there's a technique called fair queuing. Google for that one, where it says, "Aha, here's an IP header for the little one, IP header for the big one. Let's mix them together. Big one, big one, big one, little one." Big one, big one. So if you do much better statistical multiplexing, you can then have the big fat flows intermix with the little flows. And fair queuing has become more or less the default across the entire Linux world since we started the buffer bloat project. I'm hoping I had a long discussion with the free switch guys about getting it right. And, fair queuing is the default, and that makes it really possible to interleave all the different kinds of packets in the world. And then you want to have that big fat flow have most of its data out on the internet. You store data in the pipe and not the queue. Store it in the pipe and not the queue. So we came up, Van Jacobson and Kathy Nichols came up with an algorithm that which lets you have a very short queue against a very long pipe. That's the coddle part of the algorithm. So FQ coddle combined fixed everything, or so we thought. And he told, and said it's very common algorithm now, and said all your packets belong to us. And but it's still not in two core places that I really care about.
Yeah. What are those?
It's in a lot of home routers, but it's not on by default.
Uh-huh.
And it's in a lot of head ends, but it's not on by default. In part, it's so good. If the ISP were to deploy this algorithm, they would see reduced demand for more bandwidth, and they would possibly lose money. The customer would be much happier, but it has largely been a bottom-up exercise in getting people to install OpenWRT, DDWRT, any third-party firmware, turn it on, and have their internet get so much better. And it's so much cheaper to get a little less bandwidth, flash your own router, and do that. But for some reason, we haven't seen a lot of deployment from the ISP yet. Go ahead.
It very often sounds like they're the ISPs, since they're generally only judged by the bandwidth numbers they can put out, whether or not they're realistic, whether or not they are sustainable, whatever. They sacrifice everything else for for those numbers. So you have 100 megabits, sure, but it's 15 milliseconds of latency, which is stupid to have on a 100 megabits. Like, should have 2, not 15.
What people need is better bandwidth, not more bandwidth. And I would hope that ISPs in competitive markets would offer that. There's quite a few ISPs in competitive markets that do it. Probably the first. So like back when I thought we were going to change the world, we finished developing FQCODL. We put it in the Linux kernel. 2 months later, Free in France put it in their next generation routers. And I figured, wow, all the ISPs will adopt this in a year and I'll be done. I hadn't turned gray yet.
Oh, and it hasn't happened.
Well, it has. There's plenty of places where you see it. It's just not in enough places yet. I go to coffee shops and I run a test we have another test called Flint, and I run the rule test from that. It'll just last a minute, and inside of 30 seconds, you'll see people start popping their heads up from their laptops because the internet stopped working. Because there's 1 to 3 seconds worth of latency in most DSL and cable uplinks still. And, I'm not that mean a person. In general, I was just trying to do some science, and I did something like 30 plus coffee shops the year before COVID, and 28 hadn't deployed this stuff. And I realized that I too was in a bubble of just being surrounded with what I had installed. I've configured it, and so they called me back and said, "Yeah, it works," and they didn't tell 2 more people to make it work. So this year, part of why I'm doing outreach like this is I hope to reach more people and say, please, we call it smart queue management, SQM. Please turn on SQM at home, turn it on for 2 friends, and everything, absolutely everything about your home networking experience will get better, especially video conferencing.
Now I'm going to go do it right now.
Well, I wouldn't necessarily do it on the router you're using right now, but go find a router you've got in a junk bin somewhere, reflash it, and try it. And I'm hoping that your experience at home will be better. And then tell 2 more people and help them too.
I will.
Okay.
Yeah, the uptake of new technology by the industry has always been quite slow. I mean, IMS is 20 years old, 21. And it's starting to be out there, which is absolutely, and only some components have really been fully adopted. Like a lot of that is still, people either don't use it or it's just a standard, and it is a problem. So I do have one quick question for you that's super interesting to me. One of the things your introduction to buffer bloat says is that for various reasons, including the gradual retirement of Windows XP, more and more network is now running over saturated links. What does Windows XP, which is by the way used to be my favorite operating system back in the day, has to do with saturated links?
Let me introduce the world to a friend of mine who should be way more famous than he is. His name is Matt Mathis. He's a really distinguished scientist now working at Google, nearing retirement. He invented this thing, or helped invent this thing called Windows scaling. And the TCP protocol has been around since, I don't know, late 80s, late 70s, I should say.
Yeah.
And he came up with a way of making TCP scale up to tens of gigabits. From at the time, it could only get to about 10 or 100 megabits. And the Windows scaling mechanism was took years to develop and years to make stable and years of theory and work for him and his team. And that's partially why the internet has scaled, is we came up with internet scaling.
Oh, wow.
And it wasn't in XP, which was cool because as speeds got higher, XP couldn't saturate the network. Linux and OS X adopted Windows scaling first, and therefore they encountered the problems of buffer bloat. And going back to the beginning of time, when XP was retired, oh my gosh, the vast...
Welcome back. We had a little bit of a network problem coupled with a person behind the keyboard problem. And welcome back, Dave. And I think we wanted to close out on a song, right? We discussed that before. And I'd be super happy to do that. It was a super interesting interview, but songs are even better.
Oh, this is one of my overall themes. Is I've written a lot of what's called folk songs. That's like a folk song, only with different words. And I have two that I've been doing. I got one about, I'm sorry, what license is your underlying code under? Is that purely a cloud service, or are you leveraging, what license are you using?
You have a lot of MIT stuff.
So if I sang a song about the GPL, that wouldn't work for you?
Yeah, they're compatible in song form.
Well, I actually have, Richard Stallman gave me permission to release this song under the terms of the comedic license.
Nice.
But the big one I've been doing is one about SpaceX. Have you watched them blowing up their rockets and stuff? How hard they struggle to do that?
We almost every day we watch together with the rest of the company. So, so first, which is under the MPL, if you need to know.
I don't have anything about the MPL, so I was thinking I'd do the one about SpaceX because they just blew up another one. And
all of our guys love SpaceX, so that would be great.
Yeah. It doesn't matter how much you try, seeing your work get blown into smithereens, you got to get up and try again. And those people really inspire me. I have a line in this song. I went to, there was a long period of time where space itself was a dead thing. The shuttle wasn't working out. And then there was did you ever hear of Spaceship One?
Yeah, I know.
Yeah.
But
I organized
first stuff they were flying almost, right?
Sorry?
One of the first missions they flew.
No, see, everyone's forgotten this what I consider to be a pivotal moment in space history. The X Prize Foundation founded a prize for the first privately owned spaceship to fly to the edge of space and back, and $20 million. And they got 30 participants, almost all of whom failed. The money was running out. And then Burt Rutan's company, Scaled Composites, came up with something that might actually work. And still nobody cared until that day they were going to try to fly it twice in a row in 3 days. And all of a sudden there was this huge influx of press interest, and they had no money at all. So they're looking for volunteers in the space world to come down and help them punch tickets and park cars. So myself and a bunch of other people organized a bunch of other sysadmins and programmers, etc., to all drive down the Mojave Desert, stay awake all night talking about space stuff. 5,000 other people, enthusiasts, punching tickets and parking cars. And we saw that first flight go really beautifully. The guy almost died. Go looking for it. Video to it. But he came back. And it was great. That was the first time I felt hope for space in 20 years. And everyone's forgotten about that moment, except me. So let me know how good the audio is if I stand up and do this song for SpaceX.
We usually have good audio here. Let's try. I mean, it's something we've been really trying to improve here on the platform. So this is going to be a great test. Well,
I mean, the Opus codec has got some problems. I would really like to be able to do 48 kilohertz 3D positional sound. Go looking for that. So I'm looking forward to how this comes out. Okay.
Sure.
Ready. I was a kid growing up. Buck Rogers always landed tail first, and yet we've never had a landing on the cool green hills of Earth. I dreamed of O'Neill colonies and living in the stars, and I thought we'd be in the asteroids and moving on to Mars. We tried Rogallo wings and other things, nitrogen tetroxide, and all I dreamed was rockets landing with their engines flaming high. And I was there for Spaceship One's last flights. I saw willing a ship to land, and all my dreams restarted then, and I regained hope for man. We tried Rogallo wings, other things, but the costs were way too high. And all I dreamed was of rockets landing with their engines flaming high. And I practiced all my landings using Kerbal Space Program as my guide. I smashed my bits on autonomous drone ships or crashed them on the side. But we just read the instructions laid out before our time, and we're sticking to landings on pad 39. We tried Rogallo wings and other things, nitrogen tetroxide, and all I dreamed was of rockets landing with our engines hanging high. Look up, I tried Rogallo wings and other things, nitrogen tetroxide. All I dreamed was of rockets landing with their engines flaming.
That was amazing, and the quality is great too. Yeah, I think Anthony will really love this.
Awesome. And my best to the guys at SpaceX that blew up another one. Keep on trying, guys. You're cheering me up. We're gonna get there.
Yeah. It's actually, as an engineer, it's often actually hard to explain to people who don't know how engineering works, that those missions are actually successes. Like,
Yes.
They were trying to test one specific thing, and it doesn't matter if the rocket blew up, because we're supposed to test, I don't know, the attitude adjustment at a certain altitude. That worked, so they're happy. Doesn't matter it actually blew up. That's the reason why they don't paint them, because there's no point. They're probably not going to be there.
They should probably have like a little X mark on the pad, X10, X whatever, kind of like. So yeah, and again, there's also a thing that I really like that SpaceX does. It's called all-up testing. So yes, they only had that one mission, but while they're at it, they try everything else, and that's not something that an engineer does, not what a scientist does. Good engineering involves trying to test as many possible variables as you can at a time, and picking up the pieces when it does blow up and figuring out what happened.
It certainly saves money, because you will find some odd bugs, even if it's software. You will find a bug you were not looking for, and it will save you one testing cycle, because you know that you have one more thing to fix. You're right. Yeah, that's a good lesson. Well, thank you so much, Dave. It was great. I'm happy you came back, because the song was fantastic, and I think you'll like the quality of the recording. So I think this platform is getting somewhere. And thank you so much for being with us. That's what a beautiful location to call us in from. And well, it was great. I mean, so we went through so many things. Go learn what buffer bloat is, guys. Try to tweak your router. See if you can help other people doing that, and we'll get a better internet. And check out SpaceX and check out bufferbloat.net. Thank you so much, Dave.
Thank you so much. Ad Astra per Aspera.